Okay guys, let's talk about organic chemistry reactions. The first reaction is combustion. There are two types of combustion reactions, complete and incomplete. Complete combustion occurs when oxygen used to burn the organic compound is enough or more than enough. So carbon dioxide is produced, while incomplete combustion occurs when oxygen used to burn the organic compound is limited or very limited. So carbon monoxide or carbon is produced instead of carbon dioxide. Carbon is produced when very limited oxygen is used to burn the organic compound. Okay, so carbon is black solid. Carbon dioxide and carbon monoxide are colorless gas. Carbon monoxide is toxic or poisonous, while carbon dioxide is harmless gas, but it can cause greenhouse effect. Okay, let's write the equation for complete combustion first. For complete combustion, for example, I have octane C8H18. It reacts with oxygen to produce carbon dioxide and water. Okay, remember the general formula of alkene is CnH2n plus 2. Okay. And for complete combustion, carbon dioxide is produced. Okay, let's balance it now. 8 carbon atoms, so it must be 8, and 18 hydrogen atoms, so it must be 9. 2 times 9, 18. And for oxygen atoms on the right side, 16. 2 times 8 plus 9, 25. So it must be 25 over 2, or if you want to produce integer reaction coefficient, that's okay. You multiply all of the reaction coefficient by 2. So 2C8 it's 18 plus 25 O2, 16 CO2 and 18 H2O. Okay, next for incomplete combustion. I use the same alkene for example. Octane reacts with oxygen to produce carbon monoxide and water. Carbon monoxide or carbon is produced instead of carbon dioxide. 8, 9, and then for oxygen atoms on the right side, 8 plus 9, 17, so it must be 17 over 2. Or in very limited oxygen, carbon is produced. Okay, 8, 9, and 17 over 2. Okay, let's check again. 8 carbon atoms, 8 carbon atoms, 18 hydrogen atoms, 18 hydrogen atoms. Oh, okay, sorry. This is only 9 oxygen atoms, right? There is no oxygen atom here, so 9 over 2. Okay. Okay, next. Next, we go to reaction of alkene. Reaction of alkene. This is substitution reaction between alkene and halogen. Alkene can react with halogen to produce halogenoalkene, and the other product is hydrogen halide. Okay, for example, I have methane reacts with Cl2 chlorine to produce CH3Cl, chloromethane, and hydrochloric acid. Okay, in this case, one hydrogen atom from alkene is removed. It's replaced by one halogen atom from here. That's why CH3Cl is produced, chloromethane is produced, and hydrogen atom removed combined together with other chlorine atom to produce hydrochloric acid. That's why the type of reaction is substitution, because hydrogen atom is replaced by other atom. Okay. In this case, we need condition UV light. Okay, next. Reactions of alkene. The type of reaction is addition. It means that the double bond is broken down into single bond, and other atoms are added to carbon atoms to form larger molecule. Okay. Okay, let's continue. It's still about addition of alkene. It has several types of addition. First is addition of alkene with halogen. For example, bromine water. Okay, bromine water. So I have ethane and it's reacted with bromine water. The double bond is broken down into single bond and two bromine atoms are added to carbon atoms. Once again, the double bond is broken down into single bond and two bromine atoms are added to carbon atoms. Remember, carbon always has 4 covalent bonds. That's why it forms a single covalent bond with its bromine atom. Okay, so 1, 2, 3, 4. Now carbon has 4 covalent bonds. Okay, there is something that we can observe from this reaction. Color change from orange or red brown to colorless. There is no special condition for this reaction, so we can conduct this experiment. We can conduct the experiment at room temperature. Okay, next. Addition with hydrogen halide, for example, it's Cl, it's Br, okay. For example, hydrochloric acid, okay. So similar reaction, I have ethene, it's reacted with hydrochloric acid, so the double bond is broken down into single bond, and hydrogen and chlorine from HCl are added to carbon atoms. There is no special condition for this reaction. Okay, next. Next, addition with hydrogen or hydrogenation. Hydrogen is added to alkene. Addition with hydrogen, or we can call this reaction hydrogenation because hydrogen is added to alkene. For example, I have ethene. It's reacted with hydrogen. Okay, as usual, the double bond is broken down into single bond, and two hydrogen atoms are added to carbon atoms. We need conditions, platinum or nickel as catalyst, and temperature of 150 Celsius degree. Okay, next, addition with steam or water vapor. This reaction is also called hydration. Hydration means water is added to the compound. That's addition with steam or hydration. For example, I have ethene and it's reacted with steam. The double bond is broken down into single bond, and hydrogen and OH are added to the compound. They are added to the carbon atom. So alkene can be hydrated to produce alcohol. In this case, ethene is hydrated with steam or water vapor to produce ethanol. This reaction needs steam as reagent and conditions, concentrated sulfuric acid or concentrated phosphoric acid or sulfuric acid as catalyst, and temperature of 300 Celsius degree and pressure of 60 atm or 6 megapascal. Okay, next. Okay, next about oxidation of alcohol. The primary alcohol, for example, ethanol, can be oxidized into carboxylic acid, ethanoic acid. Okay, so once again, alcohol is oxidized into carboxylic acid. Okay, So when ethanol is oxidized, ethanoic acid is produced. The reagent needed is warm acidified potassium manganate 7 solution. Okay, potassium manganate 7 solution. Okay, and the condition needed, the other condition needed is heat. There is something that we can observe from this reaction, color change from purple to colorless. Once again, there is color change from purple to colorless in this reaction. Okay, next, esterification. Esterification is formation of ester, carboxylic acid reacts with alcohol to produce ester and water. The reaction is reversible. Okay, so we have to use double arrows. So once again, carboxylic acid reacts with alcohol to produce ester, and the other product formed is water. For example, I have ethanoic acid. It's reacted with methanol. Okay, so this is the basic reaction mechanism. Oh, it's from carboxylic acid and hydrogen from alcohol are removed. They combine together to produce water. That's why water is produced in esterification, and the remaining molecules combine together to produce ester. CH3, C double bond O, O, CH3. So this is the ester produced. Can you give name for this ester? Methyl. So the name of the alkyl must be mentioned first. The alkyl is from alcohol, methyl, and the remaining is from carboxylic acid, methyl ethanoate. So once again, the alkyl is from alcohol. The name of the alkyl must be mentioned first, methyl, and the remaining is from carboxylic acid, but you have to give suffix oate. This is from ethanoic acid because it has 2 carbon atoms with suffix oate, ethanoate, methyl ethanoate. So this is the ester produced. Esterification needs condition. Concentrated strong acid, we usually use sulfuric acid as catalyst. Concentrated strong acid, in this case sulfuric acid as catalyst, and heat. Okay, next about dehydration of alcohol. Remember about hydration of alkene? This one, hydration of alkene with steam. Alkene is hydrated with steam to produce alcohol. This one. How about dehydration? Dehydration is the opposite of hydration. So water is lost from the compound. water is lost from compound. Okay, for example, I have ethanol. It's dehydrated, so water is lost from this compound to produce ethene, alkene, and water. The condition needed is concentrated phosphoric acid or sulfuric acid as dehydrating agent and you can use hot aluminum oxide also, and heat is needed. Okay. The last one is about cracking. So, cracking, what is cracking? So, the longer chain is broken down into smaller chain or shorter chain. Okay, so the longer chain is broken down into shorter chain or larger chain, larger molecule is broken down into smaller molecule. That's cracking. Okay, so for cracking, for reaction in cracking, you just need to balance the equation. Okay, you just need to balance the equation, and the condition needed is catalyst, zeolite, zeolite as catalyst, and high temperature. Usually we use 500 Celsius degree. Okay, next about fermentation. Fermentation. So glucose or simple sugar is converted into alcohol, in this case ethanol, and the other product is produced, carbon dioxide. The molecular formula of glucose is C6, it's 12O6, and the molecular formula of ethanol is C2, it's 5O8, and carbon dioxide. It's not balanced yet, you have to balance it first. So 2, 2. Okay, let's check again. Okay, let's check. So, mm, 4 plus, let's check. So C4, okay, 4 carbon atoms. Okay, for carbon atoms, 4 plus 2, it's 6. Okay, 6 and 6 times 2. For hydrogen atoms, 6 times 2, 12. And for oxygen, 2 plus 4, 6. Okay, it's balanced. Okay, next. Reagent and condition needed. The glucose used must be aqueous or solution. And then we use yeast as biological catalyst. It produces enzyme as biological catalyst, okay. And then the temperature must be warm, so it's about 37 Celsius degree, warm temperature, and the pH must be neutral and anaerobic or in the absence of oxygen, because the yeast cannot survive if there is oxygen, and these conditions are needed so yeast can survive. And then remember, the ethanol produced must be separated by using fractional distillation. Okay, so once again, the ethanol produced must be separated from the reaction mixture by using fractional distillation.